The next relationship that we are going to look at kind of extends the previous one, where if we were to take those two chords, and actually in the previous picture I just realized I drew secants, but it still works the same way, where if we just ended those lines at the edge of the circle, those would represent chords. So here, if we were to just take that intersection and drag it so that it's outside the circle, and now it's an exterior angle, and we have two secants now. They're no longer chords. Very similar idea to show that the angle created by the intersection of two secants that is outside of the circle is half the difference of the measures of the two intercepted arcs. So just as I did in the last picture, I drew a chord in our circle to create a triangle. I also labeled the two intercepted arcs, x and y, and we were trying to find the measure a. So what I did first was I said, if I have this intercepted arc x, then the inscribed angle would be half of the measure of the intercepted arc. So this angle here, which encloses that arc, is 1/2 x. Same with the other arc. Here, this intercepted arc has a measure of y, so the inscribed angle that encloses that arc is 1/2 y. And just like we used that reasoning last time, this 1/2 x is an exterior angle of this triangle. So we can use that formula that the exterior angle is equal to the sum of the two other interior angles. So 1/2 x is equal to 1/2 y plus a. Then if we were to solve for a, move the y to the other side through subtraction, and then I pulled out the 1/2 into the front because it's a factor. So I pulled out 1/2, and I have 1/2 the quantity x minus y equals a. So the measure of the angle created by the intersection of these two secants equals half of the difference in the measures of the two intercepted arcs. We can continue this idea to talk about a secant and a tangent. So all we did was take that one secant and move it so that it only intersects that circle at one point. I drew in that chord to create a triangle, and then the same reasoning applies. So I'm looking for the measure of angle A here. If we look at the two intercepted arcs, we have arc x, and we have arc y. Arc x, we know that the inscribed angle would be 1/2 x. And for arc y, the inscribed angle that encloses that arc would be 1/2 y. Then this 1/2 x is the exterior angle of this triangle here. So just like as in the last one, we have 1/2 x equals 1/2 y plus a, because the exterior angle is equal to the sum of the two other interior angles. If we move the y to the other side through subtraction, we have 1/2 x minus 1/2 y equals a. We can pull that 1/2 out. We have half times x minus y gives us a. So here, the angle created by the intersection of the secant and a tangent outside of the circle, so it's an exterior angle, is equal to half of the difference of the intercepted arcs.